We're here for our Temporal Space Camp webinar, our second of three. I'm Hannah. I'm on the marketing team here at Temporal, so I'll be kind of doing it along with Alex today. So, Alex, if you want to introduce yourself, and we can get going.
Sure thing, Hannah. Thank you. I'm Alex Garnett. I am a developer advocate and developer educator here at Temporal. So I work on some of our docs and courses and everything in between. Today, we're going to be doing a session called Building Reliable Distributed Systems with Temporal, Error Handling, and Workflow Management. This is going to be a fairly introductory introduction to Temporal, and we'll show off afterwards a little demo, some of the Temporal Web UI, and an example workflow so you can see what debugging and development look like in a Temporal application stack. I'll get started. All right, so what we're going to do today is review modern applications and talk about why Temporal is a good fit for architectures you might have already encountered. We're going to introduce durable execution and temporal. We're going to review an example temporal application. We'll see temporal in action, and we'll recover from some failures. Pretty good. All right. Modern applications are generally distributed systems, which means going from the draw an owl stage, usually entails, look, I've got some circles, I've got some nice feats, and now my feats have to run in the Kubernetes cluster. And it's like, oh, it seems like you might have skipped a step there. And that's a function of what a modern robust deployment looks like and what learning how to scale up your software in production actually entails. Modern apps often have their functionality split across many microservices. They're all accessed via specific network endpoints that have to be chosen and WireGuarded very specifically. And you're probably running multiple replicas of every individual service in your stack. And so for every toy application we show off, that's like, here's the starter, here's the worker. What you actually have in practice in a real deployment is dozens of those workers, all running in replicas, all communicating over different ingress layers. And so when you scale up, things get complicated. What kind of things go wrong in a distributed system like this? Well, for one thing, external APIs go down. You have to code around unexpected failures that aren't even your fault. Sometimes, anything that your application is talking to can break, and you don't want that to cause a loss of state, a loss of data, or any kind of unexpected issues on your end. So typically you have to build in all the failure handling logic, all the retry, all the recovery policies into your own application on your side. Databases could go offline or fail. You could lose a region of your AWS deployment. You could stop being able to make web requests. This is why you often see Redis used as like a caching layer before writing to a remote database. That provides scalability and it provides some more tolerance. But again, these are decisions you have to make for every application ordinarily. Your queues back up. Whenever I'm giving this pitch at conference booths, I always talk about how pretty much every modern distributed application is just queues on top of queues on top of queues. You have to have your dead letter queue and your red letter queue and your scarlet letter queue. No, I'm just kidding. But in practice, you wind up having a lot of messages just being passed back and forth, and you spend a lot of time optimizing for how those messages are sent all across your application stack. Things time out. Sometimes a request will time out when you want it to because the request was no longer fresh, right? If you had like a stock purchase order and that's not able to be completed within a certain number of seconds, you probably just want to expire that and return something to the user. Some things time out when you don't want them to, and you have to build in logic to handle both of those contexts. And there are lots of other challenges. Sharing state across different parts of your application stack is something that you have to work out. Like you've got to have one part of your front end querying one part of your back end, which queries another part of your back end. And those all have to be kept consistent or what's sometimes called eventually consistent when you're trying to replicate data across different parts of your stack over time so you can be sure it's never going to return bad data when you don't want it to. Something has to sit in the middle across all these parts of your application that can be trusted to return state to each of them. Guaranteeing idempotent transactions. If you make the same request multiple times, You don't want that to log multiple actions on the back end, right? If somebody clicks their browser icon, buy shoes, buy shoes, buy shoes, they probably only want to buy a certain number of shoes, right? These are things you have to build in and support. Manage long-running processes. Whether you have your application deployed via systemd services or Kubernetes or any other part of a typical Linux open source stack, there's all these different mechanisms by which you can check and make sure nothing's fallen over, right? Nothing has gone unhealthy. Nothing in your deployment has turned from green to red. And then what you do in the event that it does. So these are all considerations that anybody building distributed systems will eventually face. And unfortunately, this is not always a ton of fun for developers. This is why the entire category of site reliability engineers exists, right? You have developers who want to work, like physicists, where they're making a perfect shaped horse in a perfect vacuum, and nothing bad can happen to the horse or the vacuum. But unfortunately, bad things happen to the horse in the vacuum all the time, and that's why there's a whole other category of engineer whose job it normally is to make these things work live in production, but you wind up decreasing your feature velocity so that way you're not having breakages or checking these assumptions that you've made for whether parts of your application stack will stay up or connect across other parts of your application environment. And that makes your systems less reliable, right? That can be hard if you can't ship a feature to improve something that you know is not working as well as it could. That ultimately decreases your overall velocity, and it can make it hard to get end-to-end visibility into what your application is doing, right? If you have to prototype or regression test just one component in a big old stack, you need to create interfaces to do that. And if you can't reliably have interfaces into every single part of your application stack, you wind up having to like stand up a whole local minikube cluster just to get basic tests to work. And you know that's not an efficient way of doing development, right? This just creates more headaches for you, and you want to be able to do things faster, and you can't always. The good news is we have the technology to fix this. For example, you might implement compensating actions. There's a design pattern called a saga pattern, which basically means certain things have to happen in sequence, right? Bill customer, withdraw from inventory, ship item, et cetera, et cetera, et cetera. If any one of those things fails, it has to fail over, right? You don't want one of those things to not happen and the next one to happen. So they all have to come off the stack in tandem, is what that means. And so you might implement compensating actions to do that. But again, you don't want to implement them from scratch every time. If it's a well understood pattern, this is just a endless, set of if then except loops, right? Load balancing, same thing. You're going to have that ingress nginx at the front of your stack that determines where requests are going to get routed. Well understood, but still takes some doing. Batch processing, figure out how to batch certain requests so you're not spamming your own internals, right? If you get, 100 requests within a few milliseconds, you don't want those to make 100 separate web requests. You want to batch them somehow. But again, you have to implement this for every project at every job. And as good as you might get at implementing all of these very standard distributed systems techniques, it's not that much fun. But what if there was a better way, an easier way? Well, we call that durable execution. Ta-da! Durable execution is crash-proof execution. What does that mean? It means that an application will never return prematurely. It will never lose the state of your application when you don't want it to. Any unexpected error, any unexpected exception that's encountered by your application will not cause it to return. It'll be able to wait. It'll be able to wait for an API to come back up, for you to rescue it with a new deploy. Any of these things that we'll show off in a demo towards the end of this presentation, it'll never crash. And that's a neat concept. We talk about this in terms of, like, oh, my code crashed again. I wrote a bug into it. But what it actually means is that nothing's going to return when you don't want it to. So you don't have to spend all of your time persisting variables out to different parts of your database before you would normally want to do that in a logical way. It is a development abstraction that automatically maintains state and recovers from failure, ensures your applications continue execution despite adverse conditions, and improves developer productivity by making applications easier to develop, scale, and support. So, crash proof. Okay, let's talk about normal execution as opposed to durable execution. Temporal is an open source, durable execution platform that reduces your code's complexity, makes your applications more reliable, and helps you deliver more features faster. I very much like that we are open source. We are a commercial open source project, meaning that you can run Temporal on your own machine, on your own laptop. We actually have a dev server built into our command line client, which I think is super cool. It means that you can just do brew install Temporal and you'll get our command line client made for interacting with remote servers, but you can also use that to just spawn a dev server. It'll run locally with just Go and SQLite. So we scale down really, really, really small to just a singleton instance on your own machine. And we also scale up really, really, really big to a big, robust deployment backed by Cassandra that we run and we manage for you. And we call that Temporal Cloud, which we'll also get to in a bit. Temporal's benefits. Temporal abstracts away a lot of the complexities around retries, rollbacks, queues, state machines, and timers. You write in your choice of programming language using temporal SDKs that are idiomatic to that language. When I say idiomatic, I mean idiomatic. I really love each of our SDK developers. They do such a phenomenal job of making sure that like our Ruby SDK actually feels like Ruby, that our Java SDK works with every Java Spring Boot deployment framework you might want. Like we have very nice native SDKs. We actually have I think at last count, 7 that are fully supported by Temporal and a few other community SDKs. So let's see if I can do it top of my head. Go, Java, Python, TypeScript, PHP, .NET, and Ruby are all supported by Temporal. And there's also a few community supported SDKs, including Haskell. If anybody is a Haskell fan, that was a contribution from the community. You deploy and run your code in your environment. Temporal uses a worker model. So Temporal itself, the Temporal service, is an orchestrator. That's your control plane. And that way you deploy the code to run wherever you want it to using temporal workers. This is nice because it gives you finer grained control over scaling and over where you want your code to actually run. And you can use temporal with sensitive data following a zero trust model where you can actually implement encryption that runs whenever data is sent to and from that control plane, to and from the orchestrator, so that you never have to worry about any sensitive data being decrypted on the temporal side. All of that happens in your environment, and you have control over how you want to ship that and where you want to stand it up. Temporal provides a fault-tolerant durability layer so that you can recover from any unexpected failure or expected failure. We'll talk about that too in your applications. Okay, let's talk about the components of a temporal application. Temporal applications have workflows, they have activities, they have workers. We use task queues to handle all that message passing. And there is the temporal service, the orchestrator itself. All right, let's get into some of these individually. Workflows are the steps of your process. When you are creating a temporal application, you are turning your application into end-to-end workflows that run some process. One customer transaction can be a workflow. One build system implementation can be a workflow. One video transcoding job can be a workflow. Some process that has to run end-to-end and track its state throughout. Temporal workflows can maintain state even after a crash. They can sleep and receive incoming messages. One of my favorite, like, ooh, it's magic demos that we do is that if you're running any temporal SDK, your sleep call, like your regular sleep call, which is normally just like block this thread for 3 seconds and do nothing, actually spawns a timer server side. So it's like you get free cron, you get like client server synchronization just by calling sleep. That's one that I'm really fond of. That some people see that and they're like, oh my goodness. It looks like it's so basic, but it does so much. And temporal applications can run and keep running for years, even surviving infrastructure failures. Any part of this application stack goes down, it can come right back up again and it can fail over very gracefully. So that way, If you're deployed in multiple regions and one of them goes down, chances are your end users won't even notice. Everything fails over automatically. And as mentioned, temporal SDKs are all written in any programming language that you choose. Essentially, this is not a low-code or a no-code solution. Temporal is you code it and we help it run better. There is a low-code temporal vendor called AutoKitty, I believe, who we work with at conferences. So if you're looking for like a diagramming model, look at them. But temporal is you write it, we make it run better. Okay. Activities are the individual component parts, the steps that your workflow takes, right? So you've got, here's your workflow that runs some end-to-end process like a CI/CD, like a customer transaction, like a build system, whatever. Activities are all the different steps taken in that system, which if you've ever worked with a build system before, you know what that looks like. Activities might call remote services, they might process some files, they might send an email. These are also steps that you code, right? The only distinction is the workflow is the end-to-end process, the activities are the different steps. Now, here's the distinction. Workflow code should be deterministic because temporal, whenever it's running one of your workflows, for every step that workflow takes, it's automatically synchronizing the server state with the client side code. So you'll see this in a second, but every different workflow component run line, almost like when you're like building a Docker container where it's like run, 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 but we do it a lot more subtly and better integrated. That's all synchronized as a different step. And so that way, Temporal is able to reconstruct the steps your workflow has taken if it ever needs to, if it ever fails over. And so workflow code has to be deterministic. You want your workflow code to run the same way end to end every time for some given input. Activities should be idempotent because activities are what fail and can get retried. So any one of those interactions with an external API or with a file system or with a database layer or anything else, these are the steps that they can just retry in a loop and you're not even going to notice if it took 4 tries as opposed to 1 for it to work. That's just totally graceful. And so those are what actually gets rerun. Workflow code, deterministic. Activities, idempotent. Architecting your code as workflows is what helps you build durable applications. Workflow code orchestrates the execution of activities, persisting the results. If an activity fails, the workflow will just run the activity again by default. You can customize this. You can make it conditional, right? If it fails due to bad input, you can say, I want to fail out of this sooner. If it fails for a certain period of time, you can fail out of it. But by default, activities will just get rerun. So you get that basic retry component right out of the box. If the application itself crashes, Temporal will automatically recreate its pre-failure state so it can continue right where it left off. Workers, as mentioned, are what actually run your workflow and activity code, and you can deploy those wherever you want. You run these on your own servers, in your own infrastructure, whatever you want to do. You can have your own worker deployment to a different region in AWS. We cover that use case really well in our docs. And you deploy those like any other application. So your workers are what actually have to scale up depending on how heavy your workloads are. And we give you all the tools to do that. The temporal service, that's the orchestrator. That's the heart of everything. That's what actually handles all this persistence and all this nice, neat, durable execution. Temporal service manages the execution of your workflows and activities using task queues. As your app completes different tasks, it'll record events server side. It'll synchronize those steps it takes every time so it has a clean history that it can just run and reconstruct as needed. And this is neat. Temporal service connections are outbound only because of how workers poll, and Temporal does not need access to your network. So we are very friendly to these kinds of zero trust environments, these deployments where we have to be very hands off. That was an architecture goal for us from the very start. And so Temporal fits very well into a bunch of deployments that would otherwise impose really significant privacy requirements. So maybe you've got temporal in a web app that looks something like this. If you look at the right-hand side of the screen in the bottom right corner here, Here's your temporal application. This is the code you wrote running in a temporal worker. That temporal application makes requests over gRPC to temporal itself. And the temporal service itself is what's handling orchestration. And then in turn, you're making outbound requests here to a web server to actually run whatever it is you need to run. And the whole thing is handled very gracefully and reliably. What happens when you run a workflow? Well, whenever you dispatch a new temporal workflow, that'll get scheduled server side, and one of your workers will pull and pick it up. This creates a new workflow execution. As the worker is running this workflow, it'll run all the local steps it needs to, and it'll also call individual activities as part of this workflow. The results of any successful activities, so the ones that work, are stored in the event history server side, and any failed activity executions are retried until the limit is reached. This is really nice for replay because it means when temporal is failing over, when it is reconstructing that state on a new worker, if your whole deployment region got blown up, it only has to rerun the steps in the workflow that were not already run by the activities because the activity results just get returned and saved in there, in effect. You'll see this in a second. It's easier if you see it. But basically, rerunning a temporal workflow and failing over is something that happens very, very quickly because the activity results are recorded. It doesn't need to rerun those effectively. So you wind up being able to reconstruct your whole state really quickly end to end. And I see we've got a question in the chat here. Does it support parallel activity execution? You bet. And the way you do that is different depending on the language constructors. And so we handle it idiomatically in every SDK. You can use condition in TypeScript. You can use Go selectors and futures. And so you can handle that however you want. Temporal is, you'll find it's like really nicely supportive of whatever patterns exist in the language you're already using. What makes temporal applications durable? Well, like I mentioned, in a crash, that workflow gets rerun and it rebuilds the state by replaying all the events that were logged server side up to when it failed over. But you don't need to rerun the activities. And the activities are typically what actually take any time at all to run if it's making some kind of outbound request. And so rebuilding the state is super quick, and you wind up being able to resume execution in a way that is almost invisible to an end user. And yes, another good question in the chat, it supports nested workflow execution. You can use a workflow as an orchestrator to call other workflows, and many people use this pattern in production where you have like one workflow that's dispatching all the other workflows. We also have schedules, we have our own cron, and we have a system of child workflows too if you want them to have inheritance. Great question. So let's talk about what goes into building a durable application. Okay, maybe we've got to make our request sequentially. If a request to an API fails, we want it to retry until it works. And we have to retry without getting rate limited. So we want to add a backoff coefficient in this case. And we want to be able to return something once we get all of the responses from that API. Well, how do we build this normally? Okay, if I'm sitting down and diagramming this, I've probably got a number of assumptions that I have already made. So say I've got a client that's got to call a service, and that service has to make a couple different API calls. One has to get an IP address, and that could fail. And so if that fails, we have to do some amount of waiting. And if that succeeds, we move on to a next call. And maybe we've got to do the exact same failover logic there. And so already you're seeing these are assumptions that you make every time in regular application development. Where temporal shines is that it helps do all of this for you out of the box. Got one more question here. When you want to ship workflows to production, considering an infrastructure as code approach, what is the right approach to manage the workflow definitions? Yeah, that's a great question. Workflows definitely can be tracked in GitHub. If you look at our code exchange on our docs, we link to a number of sample workflow definitions that have community contributed. And when you're revising your temporal code, when you're versioning it, there's a few different strategies that we provide to help you version your temporal applications. One we call patching, so you can basically define branches in your application for different code paths. And so you can say, if this is the old version of the workflow, file branch A. This is the newer version of the workflow, follow branch B. We also support a feature very recently advanced to public preview called worker versioning, which lets you use rainbow deployments and you can fix certain versions of your deployment to only run certain code paths. So you can say, like 20% of my live deployment is running code path A and 60% of my new workers are all running version B, and you'll route the requests accordingly. Is there an easy way to monitor errors and their types, allowing filtering based on the stack trace in the error message? I'm so glad you asked. That's coming up in a demo in just a few minutes. In fact, let's do it now. All right, I'm just gonna change what I'm screen sharing really quick so I can share my whole screen. So just give me 1 second here, because that'll work better. Here I have the Temporal Web UI. This runs as part of our development server. And so if you grab Temporal from Brew and you just do a Temporal server start dev, that will spawn this web UI and you will have a Temporal service running on your own machine. I am going to kick off a sample workflow that we have that simulates ordering some shoes, like I mentioned earlier. And this has some dummied activities that allow approval from an order, they process some payment, they make an industry reservation or inventory reservation, and then they deliver that order. We've also bootstrapped it with some shoes and a fake credit card number that we're going to use to purchase those shoes. And we have it running some activities, which you can see here, and we'll get into all of this as we go. All right, so let's kick it off. Okay, we've got a worker running here. That worker is going to receive the workflow we just kicked off. I'll refresh the web UI, and you can see we have a running workflow here. Okay. Right now, you can see the input that was provided as part of this workflow. So you can see both the input, which includes the items and the credit card number, and you can see all the steps that have been logged on the server side so far. Okay, this has been running for 30 seconds or so. Here's all the events that were logged to the event history since I kicked off this order. And that's basically everything in here. It's run up to this require approval activity, okay, which is not very far along, right? We're about to hear. We're awaiting require approval. And what this shows us is that running just a little bit of code is already generating a number of server-side events that could later be used to reconstruct workflow state if needed. Now, what this require approval step does is it actually awaits the workflow for some input. This way, if we were integrating this order management system into, like a more full application stack, and this required somebody else using some internal front end to say, hey, I want to approve or reject this order, we could block and we could wait for a signal to come in. Now, normally you would expect that to come in from a different part of your application stack, but because we're looking at the web UI right now, I can just send that signal right here. Okay. And I'm going to send this a signal called approve order. This is one of the defined responses that this workflow knows how to take from a different part of your application. I'll send approve order, and automatically you can see that get logged in the event history. Here we have a signal that was received. There were no additional input parameters here because this is just kind of a simple out of the box example. And it was after that able to run all three of these other activities: process payment, reserve inventory, and deliver order. They all ran pretty much instantaneously in this case because this is a sample application. They're not actually going and, charging anyone's credit card, but you can see it was then able to get through the remaining activities defined in this workflow: process payment, reserve order, deliver order, and it logged all of that to the workflow's event history. Each of these returned some kind of output, and so you can see for every activity that gets run, you wind up having the input and the output persisted. That way, if the workflow does have to fail over, it's able to just grab the results of the activities that were already recorded successfully. They all ran on the first try. You can see attempt 1 here, and we got to a workflow completed state. Workflow execution completed, payment process for 2 items, it was returned successfully, and we have the result stored right here. We go back to our list of running workflows here in this local temporal cluster, and you can see we have so far run one workflow totally successfully. We are happy. All right, now let's take a look at some other conditions that we can have here. In this workflow definition, I have a list of non-retriable error types. These are going to be errors that, if we encounter them, will not get automatically retried and will fail over very, very quickly. Okay? This is useful in cases where if you do hit an error, you don't want it to retry. You want it to just return right away, right out of the box. So what I'm going to do is I am just going to mess with our credit card number here that we have as a sample, because what it does here is it checks if the expiration date is wrong, and if the expiration date is wrong, if that credit card's already expired, it'll fail over automatically. Okay, I've made that change, I've saved it, and I am now going to kick off a new worker, or a new workflow rather. The worker's already there. Kick off a new workflow, okay, and we're running here. All right, so far so good. This workflow is running just like the last one. I am going to send a signal. I'm going to try to approve the order again. Okay. Oops. I sent that signal, and then immediately it was able to progress as far as the process payment activity, which it automatically failed because, thanks to the great question I got earlier in this webinar, we had a certain kind of error that we wanted to filter on, and we wanted that to return automatically. And so we get this retry state non-retriable failure, right? This enabled us to fail early and fail often in cases where we don't want that retry functionality. If we just want the workflow to be able to fail over quickly because we know that it's got some bad data and we don't want to spend all of our time waiting in a retry loop. All right. Now let's fix this and try something else. Okay, now what I'm going to do is I'm going to uncomment some code because this is going to make one of these activities fail the first few times we try to run it. Okay, let's do it this way. Whoops, I think oh, I see what I did here. Did not uncomment that line. There we go. All right, very good. We're going to kick off another new workflow. Okay, here we go. Once more, waiting for that first require approval signal. I will go ahead and send that. And now we're going to have this interesting case where reserve inventory is failing the first few times. Okay. We're at a pending activity. We can see here that it's trying to run. It's now showing us, okay, this is turning orange. We know it hasn't worked the first time, right? We're benefiting already from Temporal's automatic retry functionality. We're now on attempt 4, and it's going to keep retrying until it gets to the 5th attempt where we've programmed it to work because we only have it dying the first 4 times just to show this off. And it's going to add a larger backoff coefficient every time. So that way you're not spamming a third-party API endpoint. You're not going to get yourself banned from trying the same API request too many times. Eventually, on the 5th attempt, you can see here from your activity results, it's able to run successfully. And we look up here, and we've got yet another successfully completed workflow. In this case, one of the activities failed the first few times, and then it was eventually able to run successfully end to end. And to an end user, this is like nothing happened, right? Maybe this part of the request took a little bit longer, but there was no additional error handling that we did on our end. We just had an activity that arbitrarily failed a few more times, and that didn't cause anything bad to happen. I can show one more case that I think is kind of neat along those lines. So instead of doing this right here, okay, what I'm going to do is I am just going to have one of our other activities just throw an error. So let's do throw new error. Uh-oh. Okay. Now we know that this makes the rest of this code path unreachable, which we'll see what happens here in a second. Okay, kick off one more new workflow. All right. I, by the way, do not Recommend naming your errors uh-oh in a real application. That's generally thought of as unhelpful. All right. We're going to send this signal approve order. All right. And we've gotten to this deliver order activity that I've screwed up and it's retrying. It turns out uh-oh is an issue. Now, this might happen too, where you've just got an issue in your code that you need to rescue yourself. But whether it's a bug that you added or is completely unexpected, what you can do is just fix it, redeploy it, and then in this case, I've got nodemon running in the background, so it's picking up and it's going to automatically have my changes in place. But you can rescue your own deployment by just pushing new code that fixes a bug and allows it to run successfully. So you can go in there, you can rescue it, you can fix it, and once again, it's able to complete successfully. So whether the bug is on your end or on some third-party dependency, it works the same way in both cases. You can go in live, you can save workflows that are running, but they can't progress further. Rather than worrying about the state of your workflow being lost, you're always able to go in there. And I think that's really powerful because it means you don't have to code as defensively. Temporal handles a lot of that potential edge casey stuff for you. Got some questions here. Temporal works for data pipelines. Yes, it does. It works very well for data pipelines. I have a code sample myself that I just added to our code exchange of using it to kick off multiple different FFmpeg transcoding jobs. And so if you're, say, Netflix and you have to generate a 720p and a 1080p version of all the content that you're putting into your video pipeline, you can have it kick off and dispatch multiple jobs. And what I have it doing is actually returning the standard out from FFmpeg that would normally just get printed to the command line. So that way we get progress updates while it's transcoding. And that works really well in a granular way. And yes, the retry number is configurable dynamically at runtime. We call all of that the retry policy that gets associated with every activity. And you can change how those are inherited depending on how you're building and shipping your temporal applications. All right. That's it for the demo. I'm just going to switch back, or actually, I can probably just do it this way at this point. Leave full screen that. All right. So when you go to production, Temporal, like I said, doesn't run your code. Your workers run your code. Temporal orchestrates your applications. You can deploy your temporal apps as you would any other applications following your own requirements, and you can scale your workers to meet your needs. All you have to do is make sure that your network can make requests on port 7233. That is the port we use for gRPC. All temporal SDK communications with the orchestrator are all just protobufs over gRPC. It's all really straightforward. And so all you need is one port to be able to orchestrate all of this. How about using signals to retry from the point of failure? That would be very possible depending on how you wanted to implement it. Typically, we use signals as a way of handling any input to a running workflow, right? So if you need to have any front end hook into a workflow that's going to be running because it has to receive some input, add a signal handler. You can also define a generic signal handler if you don't want to add one for every case and you want to be sending different signals and just testing them conditionally on whatever they're named. You can do that too. And so typically, if you have a failure in a workflow, it depends like, is that an intentional failure? If it's a failure state that you're anticipating, you can make it, if this activity fails, you want it to block and wait for a signal. That's conditional logic. That's totally doable. Workflow stage, manage at data store. What does visibility store manage? We have active passive setup with passive PostgreSQL replication. Okay. What that question is about is Temporal runs several different services internally. And same thing, if you're running them in like a local client, you don't even notice that because it's all running as part of a singleton. If you're in a production deployment of Temporal, you're going to have a visibility service and an archival service and so on. And those can all run in different replicas. And that's what makes Temporal so responsive and so scalable. The visibility store is what enables you to actually query and use the web UI and derive metrics. And so that way there's different parts of the temporal stack that are all running and they help support different aspects of observability, of querying, and of persisting this data in a way that you then have access to over time. A production temporal service is MIT licensed. You can scale it as needed. We provide Helm charts to help you do so. And like I said, you'll use replicas of some aspects of the temporal orchestrator stack so you can fit to your own needs. Of course, that can be pretty challenging, right? When we're talking about deploying like multiple different versions of each service with Kubernetes and having to have a Postgres or a Cassandra backend with failover, that can be a tricky thing to ship on your own. And that's why we offer Temporal Cloud, which is our managed bulletproof offering of Temporal. Temporal Cloud is great. It's at feature parity with all the open source features. And so we don't gatekeep any of that. We just give you a really, really powerful, robust deployment managed by our own experts here at Temporal. You're in good company with Temporal. We have a lot of logos that we are always very proud to show off who are using it in various capacities. I think every Taco Bell order is a temporal workflow, which is a fun one for us to talk about. And you can see many, many other cases, people using us for build pipelines, data pipelines, customer transactions, and everything in between. And you can join the temporal community right now. We have an active discourse forum, we have a Slack community, and like I keep mentioning, we have great docs and code samples contributed that you can find at docs.temporal.io or click through on our code exchange to see how community members are using and deploying temporal. We also have many courses that you can take at learn.temporal.io, and we sometimes offer those courses live. I personally offer those courses live, so you can keep in touch with our community. And if you're looking to onboard yourself or your team, we would love you to get in touch. And if you have any other questions about Temporal, or if you want to join an upcoming meetup, please take a look. Now, I see Hannah, you're back. I have some questions here I'm going to try to get to, I think, just for a minute before we wrap up, because we got some pretty in-depth ones, and then we will go from here.
Sounds
Does the
great.
SDK provide all the metadata related to the workflow, input data configuration policy available to all the activities? That's a great question. Yeah. Each of our SDKs give you everything you need to bootstrap a temporal workflow. And so when you're defining like the retry policy for a given activity, you just pass that as a dictionary or an object or a struct, depending on the language, along with the activity that you're calling. The SDKs help you do all of that. And we've got lots of good examples there in our docs. Does dynamic config apply in activities retry options? Dynamic config, I'm not sure what you're referring to there. Dynamic configuration is, at least when we say dynamic configuration, that is a way of bootstrapping our open source server when you're deploying it. And so there's a few different dynamic configuration options that we let you specify at deploy time. That's not quite the same thing as the retry policy. Those are two different concepts. What if I have an order or payment workflow in Temporal and I'm at an activity step that's waiting for a response from a partner? The response doesn't happen, and the partner, through another communication channel like email, tells me they processed my request. What to do? First idea is to update the status of my order and payment in the DB and somehow tell my activity that it's completed so the workflow can continue its execution. Yeah, this for me would be a case where what you want to do is you want to block your workflow execution and wait for either an activity to return or a signal to come in, right? Because I think in this case, we want to be able to handle processes that are both in band in terms of your orchestration and out of band, right? You might get something manual, and you can do that. You can figure out ways of blocking conditionally to either get a process to return or just design your workflow so that way you can advance it with a signal or something else if need be. Last question, if I have a workflow with say 5 activities and activity 3 failed and that's due to a backend issue, once the backend issue has been fixed, are you suggesting we can use, so you might not even need a signal to retry your activity 3, and it depends how you've orchestrated that. Like if so you've got a saga pattern where these all have to run linearly and activity 3 is failing, you don't necessarily need to signal it. It might just be failing endlessly and failing in a loop and failing gracefully. And once the backend issue is fixed, it'll automatically recover and retry. So you don't need signals to kick off retries necessarily. It really depends on how you want your infrastructure to work, but Temporal can do a lot of that automatically. That's one of its key features. How do you support reliability of distributed machine learning systems? Also a great question. We really like talking about temporal for AI because we have really good product fitness out of the box in effect. What that means is, as we say, every AI problem that's not linear algebra is basically an orchestration problem, and we're a really good orchestrator, right? So whether it's about retaining LLM context over the course of a conversation, or if it's about needing to do multiple different training runs, right, in the back end and being able to constantly rerun and retrain these ML systems, Temporal's a very good generic orchestrator, and it handles any orchestration case that you can think of fairly well. So we give you all the tools, all the juice, all the backend magic you need, and then you can just code it as you would, but not worry about hitting scaling bottlenecks or losing state partway through. Great question. I think that is all the questions, and I want to thank everyone for being so engaged in the webinar today and asking such good questions. We do have some blog posts about Temporal's applicability for AI, so I'd encourage you to check out our blog. We're doing a lot more content along those lines this summer too, so it's a great time for that. And over to you, Hannah.
Great. Well, thank you everyone for joining. We will have the recorded and the deck sent out probably by Monday, maybe a little earlier. But thank you all for joining and have a great rest of your day.
Thanks, folks.